Gate doubt solving session. Welcome to the Ekeeda YouTube channel. Good evening, Mohammed. Is my screen visible? Yes. So for the people who don't know, you can just download the Ekeeda app from the Play Store, or in the live chat you can see the description in the description box. Uh, you are able to see a link, right? You can click on that link and download the app, right? We have academic courses. Hi Chandra, welcome to the class. So we have academic courses, we have competitive exam courses, we have professional courses for all branches of engineering, right? So you can download the app and have a look on the uh, application, right? So if you are a new user, you can use gold 11 code so that you will get a 3 days unlimited access to the courses which are there on the Ekeeda app, and you can go through and decide whether you want to take or no, right? So you'll have complete access. We have all recorded classes, and whatever doubts you have in the recorded classes, you can attend the live classes like this on the YouTube channel and mm, get your doubts cleared. Okay, so we have three different passes if you want to take up the subscription: silver pass, gold pass, and platinum pass. So for more details you can visit the app, or you can just contact this number for any inquiry regarding the courses and all. Okay, so this is about our app. Do have a look on that. So today we are doing the steel structures doubt solving session. So in the previous session we have already completed the plastic analysis, right? So today we will be doing the test solutions first for bolted and welded connections. This test was conducted yesterday on the app, right? Every Sundays we have tests which are going to be conducted. So this is basically for the people who are preparing for your gate exam or any other competitive exam, but majorly focusing on the gate exam. Okay, so the test was conducted for 20 marks. There were 10 questions of 1 mark each, and 5 questions of 2 marks each, so totally 20 marks. So we will solve them, and if time permits we also will have certain additional problems on bolted and welded connections. We will try to do those also. Okay, so let's get started. For whoever knows the hi Jeevan, hi Jeeva, welcome to the class. So let's get started. This is the first question. For the people who knows the answers, can comment in the comment section with the question number. Type the question number first, and then beside that you type which answer is correct. Please do type the question number, without which I will not be able to understand for which question you are answering. Okay, so the first question of today's is this. So what is it? What is the maximum number of 20 dia bolts? So the dia of bolt given is how much? 20 that can be accommodated in a single row. So there's a single row on a 140 wide flat strip. Okay, so there's a flat strip whose width is how much? Whose width is 140 used as one of the steel elements involved in the process of steel design. Okay, so how many single row bolts can I accommodate is what is asked in the question. Okay, so this is the given diameter of the bolt. Generally, whatever is the diameter, that will is your nominal diameter. So whatever diameter will be given, you consider that to be your nominal diameter of the bolt. Okay, so this is the given, sorry, whatever is the diameter given to you. For that, if you add 2 you will get your nominal diameter. So nominal diameter, I will call it as phi n. This is the given diameter. Given diameter. Okay, nominal diameter will be given diameter plus 2 So how much will it be? 20 plus mm, that will be 22 mm. So once you calculate the nominal diameter, you will have to calculate what is the minimum pitch we have to give. Pitch is what? Pitch is the distance from the ends. Okay, so the minimum pitch or the minimum distance between bolts or the sides. So how will you calculate minimum pitch? The standard for bolted connection minimum pitch is nothing but 2.5 d naught. See, sometimes nominal diameter is also called as d naught, so don't get confused. You can write 2.5 times of d naught or 2.5 times of phi n. Okay, this is your minimum pitch. Then you have to calculate the minimum end or side distance. These both are compulsory. Minimum end or side distance. This is also standard. According to the code, it is how much? 1.5 d naught or 1.5 phi of n. Okay. So based on that, how will you do the calculation? So this is nothing but 0.5 of your d naught or your phi n is how much? 22 mm. So this into 22, this into, okay, let me just do a small correction. This is just a d or phi. This is just a d or phi, which is 20. So I'll call this d or phi. Given diameter multiplied by 2.5 will give you minimum pitch. Nominal diameter multiplied by 1.5 will give you the minimum end or side distance. Okay, so this will be 50 mm. And how much is minimum end or side distance? 1.5 of phi n. Phi n is nothing but 22. So that will be your 33 mm. Now, what is your final work? Your final work is to find the number of bolts which will fit. So what I will call, let n, I'll call n as the number of bolts. Number of bolts. Then what will happen is, see, edge distance, two sides you have to give edge distance. So 2 into 33. Okay. Then plus the pitch is nothing but, see, this is your edge distance. I'll give you a line like this and I'll give a line like this. Okay, here and here. Or what we can do is like this. I have to give the bolts. Let me do a different figure for you so that it will be easy to understand. Like this. This is given as 140 mm. Right. Now edge distance, how much are you giving edge distance? Here this one is 33 mm and this here also is how much? 33 mm. So in 140, 33 and 33 is gone for edge or side distance only, right? Then after that, say consider there is one bolt like this, one bolt like this, one bolt like this. Already this bolt has dia, right? So in between pitch, how much I have to give? See, I have calculated. Minimum pitch is the minimum distance between two bolts. I will call it as what? Pitch. Okay. So this is already we got as 150 mm. So the number of bolts will be one less than, the number of pitch will be one less than the bolt. Okay. So one less than the number of bolt will be the number of pitch. That means, say if there are three bolts here, for example, this is just an example I have given. Okay. If there are three bolts, how many pitch we'll have? For three bolts, we'll have two pitch, right? So that's why n minus 1. Suppose there are 3 bolts, n minus 1 number of pitches should be there. Okay. So this total should be equal to the width. This total should be equal to the width, which is nothing but 140 mm. I hope you understood. So this is your side distance and the pitch will be 1 less than the number of bolts into the pitch distance. That will give you total 140 mm. See, you cannot randomly say that, okay, 20 mm dia bolt is there, no? So what I will do, I'll do 140 by 20 and give the value of 7 bolts. We cannot do like that. If you are giving 7 bolts, they have to touch each other and come like this. So it cannot be possible like that. You have to give minimum pitch between the bolts and minimum edge side distances at the ends. Only after you provide this, you can decide on the number of bolts which you can give. Okay, so on a calculation, how much will this be? 66 plus 50n minus 50 is equal to 140. So 50n will be what? 140 minus 66 plus 50. So that is nothing but 190 minus 66, 190 minus 66 by 50. Okay, so your implies n is equal to what? 190 minus 66 by 50. So on calculation, you will get the value of n equal to 2.48. Okay, so for n is equal to 2.48, what you will have to do, you cannot round it off. See, you cannot give 0.48 bolt, no, you can give only a integer value of bolt. Either you can give 2 bolts or 3 bolts. Generally what you do, you round it off to the nearest decimal. So if it is saying 2.48, this is less than 0.5, so you can give what? 2 number of bolts. So this will be your correct answer. Okay, so in this what I explained you, the standard which you have to remember is the minimum pitch is given by 2.5d, where d is the given diameter of the bolt and the minimum edge side distance is nothing but 1.5 of d naught, where d naught is the nominal diameter of the bolt. How will you calculate the nominal diameter of the bolt? Just add 2 mm to the diameter of the bolt given, you will get your nominal diameter. And then for number of bolts, you have to use this formula. The total width will be equal to 2 times of end side distance plus n minus 1 times of the minimum pitch. That will give you the formula. Okay, I hope this is clear, everyone. Is this clear? Shall we go ahead and move on to the next question? Okay, so moving on to the next question. So what does this say? This is about a welded connection. This is for the welded connection. Okay, so two plates of thickness 18 mm and 16 mm. So there is one plate here. There's one plate here which is of 18 mm thickness. Okay, and there's one more plate here which is of 16 mm thickness. This is to be joined by a single V-groove weld. So if you observe, there is a V-groove weld here. Single V-groove weld we are going to use. Single means what? Only one weld, one direction weld or one side weld we are going to do. Okay. Then assume an effective length of 300 mm. So the effective length is given as how much? 300 mm, right? And Fe 410 grade steel plates. So this steel plates is of what? Fe 410 grade. Okay, effective length is nothing but the total length what we have, which is nothing but your 300 mm, right? And used and the welds are shape welded. So the type of weld they have given is a shape welded. Why? Because they have told it is a V groove weld. Okay. The strength of the weld is given by. So generally the strength of your, so this type of weld is called as your butt weld. Okay. So your V type of weld is called as your butt weld. So the strength of butt weld is generally governed by your yield criteria. Yielding criteria. So what is the formula? That is nothing but TW implies your Fy by gamma MW into TW into TE. Okay. So how will you go about this problem? What is Fy? Fy is the grade which they have given you. So Fy is nothing but 410 Newton per mm square. Okay, then how will you calculate TE? So the TE is nothing but effective throat thickness. So TE is nothing but what? Effective uh, throat thickness. So this is nothing but 5 by 8 of T. So here the T what we can take is out of these two we can take the smaller value. Okay. So here T is nothing but 18 mm, 16 mm, smaller value, smaller of both. I will write like this. So what will be your T? 5 by 8 of 16. That is nothing but 10 mm. So suppose if both the plates are of same size, we can use the single value for the calculation. Okay. Here TW is nothing but the effective length what they have given. Okay. Effective length is nothing but 300 mm is given to you in the question. Ah. Now what do we want? What do we have to calculate here? So if you observe, this is nothing but the strength of the weld. So just gamma MW, gamma MW will be a standard value of 1.64. We have to choose for welded connection. Okay. So you have to just put those values and do the further calculation. Okay. So generally for different type of welds, the gamma value will be varying. Okay. Now because this is a butt weld, we have to use the gamma value as equal to 1.64. Say suppose in the question they have given a shop weld. So for shop weld you can choose it to be equal to 1.25. So for different type of welds you can accordingly choose the value of gamma. Okay. So gamma MW. So in this particular case, how much is the value of gamma MW standard? So let me do the substitution. 410 divided by 1.64. So this is according to the type of weld. So here gamma MW can be chosen as 1.64 and TW, the total effective width or length, is given as 300 and the effective throat thickness is 5 by 8 of your minimum throat, minimum thickness of whichever plate it is. So how much we got? This we got as 10. So this and total will be equal to how much? 6000 kilo Newton. Okay. So what will be the exact? The strength of the weld is equal to 6000. You should give the answer as 6000. They have asked in the nearest integer. So correctly we are getting as 600. So directly you can write the value as to be equal to 600. Okay, next. Moving on to the third question. So this is a theory question, right? For a single unequal angle preferred for making connection is the longer one, shorter one, any of the two, longer if bolted and shorter if welded. So which is your correct answer if you're going for a single unequal angle? Okay, so if you have a single unequal angle, what is unequal angle? Say one you have long end like this, one you have short end like this. Okay, this is short length, say T1 I'll call this. This I'll call as, sorry, L1 let us call. This will call as L2. So here L2 is greater than L1. So in that case, which one will we use? Either if you're going for bolting or welding, suppose you want to connect it to a gadget plate or anything, which side you will consider? So the answer for this is the longer side. You have to do the connection at the longer side. Whether you are going for bolted or welded, it is not different. In the option D, it is saying longer if bolted, shorter if welded. Shorter if welded is not correct. Whether you are going for longer bolted or welded connection, it is both longer. Any of the two is also not correct. Shorter one is also not correct. The reason why we go for longer weld is longer side for the connections is, if you go for the longer side, the effect of the shear lag will be reduced. Shear lag, effect of shear lag will be reduced. If you want to know more details about the theory portion of all these things, you can go to the app and take up the complete course subscription, so that you can go with all the theory concepts and the numericals of the steel structures for your gate exam. Okay. Next, moving on to the fourth question. Which forces are large and space for the bolt connection length is limited? Which one of the following bolt is preferred? So, suppose you have very large forces. Large forces means what? Very huge amount of forces is coming onto your structure, but the length which is available for providing the number of bolts is nothing but limited for you. So in that case, for which type of bolt will you choose? They are asking black bolt, closed tolerance bolt, HSFG bolt, ribbed bolt. So we have to go for HSFG bolt because these are very, very strong bolts and can resist that large forces which are coming onto the structure. Okay, understood? I hope it's clear. Right, now let us get into the next question. So as per IS 800 2007, so this is the code which we are using for any steel structure design. Okay, you have to by heart the some of the standards which are used for different types of calculation. Okay, so that will be helpful for you for the exam. Right, now according to this code, the distance between the center of any two adjacent fasteners shall not exceed dash T or dash mm for tracking bolt, whoever is less, where T is thickness of thinner plate. Now for this, the exact answer is 32 300. Now for this you have to refer to your clause in, if you have an IS 800 2007 code, please go to clause number 10.2.3.1. So in that we have they have given the standard values 30 T or 300 mm. 30 times of thickness. What is T? Thickness of the thinner plate. Suppose there are two plates, the thickness of the thinner plate. Say for this example only, if you choose whatever example we have done here, one plate is 18 mm, one plate is another one is 16 mm. So what we'll do? 30 into 16 or 300, whichever is less, we generally adopt that particular value. Okay, so which is less? This will give you 480 mm and this will give you 300 mm. So you will choose 300 mm because you have to go for a lesser value. Okay, but the standard is 32T or 300. So you will have to remember this standard value for doing your calculation. Okay, next question. We'll move ahead and go on to your next question. So what does the next question have to tell us? The rivets subjected to unpredictable tension during the placement are, so for different types of rivet there is different types of forces, but for which type of rivet do we have unpredictable tension which is coming into existence? I mean, like, you might have not estimated that there is going to be any tension force in the rivet, but get we get it. Okay, so how much is that? Shop rivet, field rivet, hot rivet, and cold rivet. Now for this, so generally the answer is hot rivet. Why? Because generally when we have a hot rivet, on cooling this, it will shrink in length as well as diameter. Okay, so there will be a shrink in length and diameter. Mohammed, for which are we getting 750 kilonewton? This one. This one, are we getting 7? Let me just check. Yes, beta, we are getting. Okay. So, array, this one, I guess. 1 minute. Yes, na, Baba, we are getting 750. Thank you. So, just did some calculation error. Okay. So, this one is 750. Correct, Mohammed, you're correct. So this one, you're getting 750. कैलकुलेटर से गलती हो गई, मैंने कुछ तो दबा दिया. ओके, दिस इज करेक्ट. मोहम्मद, you're correct. Okay, चलो. So what I told, so whenever we use hot rivet, what will happen on cooling of the hot rivet, your rivet will, or the length of the rivet will be reduced as well as the diameter will be reduced. So because of this, what will happen? There will be shortening of rivet. Okay. So the ports which are there used for connecting, they will become tighter, and this will reduce in some unpredictable amount of tension. So we cannot go for hot rivets. I mean, we can go, but there is unpredictable tension if you're going for hot rivets. Generally, rivets are not much used these days. Okay. Next question. Two plates are welded as shown in the figure. So they've given you a figure and they've told you that there is a welding done between the two plates like this. So the plates are, one is horizontal plate and one is inclined at a degree 115. What would be the value of effective throat thickness for the design? He has given the size of weld to be equal to S. Now this is also a standard. So this is according to your IS 800 2007. You have to refer table number 22. So all the standards are given. So for this, the throat thickness is nothing but 0.5 times of S. Now this is if the angle between the plates is 114 degree to 120 degree. So if you have angle between the plates equal to 114 to 120 degree, then the throat thickness is 0.5 S. So which will be the correct answer? This is going to be your correct answer. Okay. Chalo then. Next question. Generally, what we can do is, I'll give you the standard values according to this table, whatever is there, so that you can just recollect. So I'm going to give you this table details. So generally, the effective throat thickness TT, this is given by K into S. Now this constant will go on changing. Okay, that is what we got as 0.5 here. Okay, so this constant goes on changing. Now suppose the angle is from 60 to 90, the value of K will be 0.7. From 91 to 100, the value of K is 0.65. From 101 to 106, the value is 0.6. From 107 to 113, this value is 0.55. And finally, from 114 to 120, the value is 0.5. So this is what is given in the table 22 of IS 800 2007. So accordingly, you can decide whatever is given to you. Okay. Chalo then, let's move ahead and go to the next question. Okay. Consider the following with regards to welding. We have to say which of the following statement is correct. Okay. First, reinforcement on weld is given due consideration in the design of welded joint. No, we don't give consideration of reinforcement. A convex fillet weld is preferred over a concave fillet weld for static loads. Yes, correct. So we have to go for convex rather than concave. Convex, we have to go for this type of welds. Okay, that is correct. Next, the maximum clear spacing between weld pieces shall be 12 point T or 200 mm, whichever is maximum in case of compression members. No, this is minimum. Okay, so this is also wrong. Then fillet welds have less residual stress as compared to butt welds. Yes, correct. Generally, fillet welds are good because they have less residual stresses when compared to your butt welds. So that is also correct. So the correct options are option number 2 as well as option number 4. Again, I would like to repeat that if you in case need to know the theory behind all these questions, please visit our Ekeeda app so that you will get the complete course of steel structures. Okay. Next, moving on to the next question. So this was question number 7. Let us move on to question number 8. A bolt weld is subjected to 60 MPa. Sorry, this one was already question number 8. This is question number 9. Okay, so the shear stress which the bolt is subjected to is 60 MPa. So I will give the notation for this as Q, 60 MPa. That's nothing but shear stress. See, whenever a problem is given, it's very important for you to write down properly what all is given. Okay. Then they have given the bond stress. So let me call the bond stress as FBR. This is as 90 MPa. So this is your bond stress. Then bearing stress I'll call FB. Okay. No, bearing bond. Okay, let us change. 40 is bond stress. 40 is bond stress. I will call bond stress as just a B. Okay, and bearing stress as BR. Now, bearing stress BR 90 MPa and bond stress B is 40. So 40 MPa of bond stress. In addition to it, there is 90 MPa of bearing stress is also acting. Then the value of the equivalent stress in MPa in the weld. Okay. Now we have a standard value according to clause number 10.5.10.2.2. What is this? This is according to as per IS 800 2007 clause number 10.5.10.2.2. So what is your effective stress equal to under root bearing stress square plus bond stress square plus bearing stress into bond stress plus 3 times of shear stress square. This is the standard formula. Right now you just go on doing your substitution. Okay, so this is your bond. So 40 square plus 90 square plus 40 into 90 plus 3 times of how much is shear? 60. 3 times of 60 square. So on calculation you will get the value equal to 155.241 MPa. Okay, so 155.24 MPa. Generally, they will give you the range. You can choose the proper rounding off according to what is given to you and you can put it. So if they ask you for one decimal place, put 155.2. If they ask you for two decimal place, you put 155.24. So generally they will choose a range like this 155.1 to 155.3. So whatever is your answer, they will give correct answer. But you should be very careful when you're choosing your answer. Okay, clear? So this is a standard formula which you have to remember for calculating what? The effective stress. Then moving on to the next question. What does the next question have to tell us? Just check. Match list 1, that is the type of connections, with list 2, that is the types of bemmers, and select the correct answer using the code given below. So you have to match what? You have to match your connections with their same criteria. Okay. Now for the first, what is first? Semi-rigid connection. Okay, let me tell you the answer for this. So the answer for this is question number 10. For the answer for this is option number C. Okay, So for semi-rigid connection, generally you will have small end rotation and they will transmit applicable moment. Okay, so this is for semi-rigid connection. Next, framed connection. So in framed connection, whenever a beam is connected to a beam or suction by means of two angle bolted to them. So like this, if you connect with bolt or angles, here one angle, here one angle, then this is nothing but your framed connection. Okay. So semi-rigid, see rigid moment will be developed, right? In semi-rigid moment, small moments will be developed and there will also be applicable transmission possible. Next, flexible connection to permit large angles of rotation and to transmit negligible moment. We go for what? Flexible connection. Okay. And then finally you have your seated connection. So when a beam is connected to a beam or suction by means of an angle at the bottom of the beam which is sharp bolted to the beam and an angle at the top of which is fillet bolted. So on bottom you will use shop bolt and on top you will use the fillet bolt for connecting your beams with beams and beam with suctions. Okay, so then we call those type as seated connection because one bolt will be seated on the other. Okay, one bolted shop bolt will be seated on the fillet bolt both at top and bottom. Okay, I hope it's clear. Right. Now let's, these are all the 1 mark questions which were given in the test conducted in the morning, yesterday morning, Sunday morning. Okay. Now we'll get into the 2 marker questions. We have 5 2 mark questions to be solved. So in the first one, this is eccentric loading problem. Now a bracket has been attached to the flange of the column. So this is a column, right? And this is a flange of the column. So like this, if the column is there, this is your flange portion. Now here one bracket is attached like this. This is called bracket and this shaded portion, this is your flange of column. What we have to do? We have to find the maximum force in the bolt. So if you observe, you can see 4 bolts here, right? So 1, 2, 3, 4. So we have to find the maximum force in the bolt. Okay. Now how will you calculate? See, first try to calculate the vertical shear force in the bolt. Vertical shear force in bolt. Okay. Now see, vertical shear force, if you see there are 2 downward forces and 1 upward force. I'll take downward force as positive, upward force as negative. Okay. So the total force is nothing but P kilonewton. Now this is for this, whatever we have calculated is for 4 bolts. Now if you want for 1 bolt, if you want the total force for 1 bolt, this is a total force taken up by these 4 bolts, 1, 2, 3, 4. So for 1 bolt, how much will the value be? It will be P by 4 kilonewton. So this is nothing but the vertical shear force in a single bolt. Okay. Now next I will try to calculate what is the twisting moment or the couple. Okay. So twisting moment or couple. Now this, if you observe, 100 into P, this force into perpendicular distance, again this is clockwise, this is also clockwise, plus 100 into P. When it comes to this particular load, this is anti-clockwise. So minus 100 into P. So this and this will get cancelled. So it will be 100 P. The total couple will be equal to the 100 P kilonewton meter. Now, next, after calculating how much is the vertical shear force in each bolt and how much is the twisting couple, we have to calculate the maximum shear force in the bolt due to this twisting moment, whichever is there. See, because it is eccentric loading, compulsory that twisting moment will come into picture. Right now, we have to calculate what the maximum shear force in bolt due to M. So what is the formula? Fm is equal to MRI by sigma R1 square. Okay. Now see here, what will happen is, see here this 30 and here this 40 will be given, no? So we have to calculate the diagonal for that. So how will you do? Hypotenuse you can take. So 30 square plus 40 square multiplied by the couple whatever we have. How much is the couple? 100 P is the couple. This should be divided with the help of 4 bolts. Right? So 4 into 30 square plus 40 square. Don't underroot it because I just want to calculate the summation R1 square. So on simplification, what will you get? So this one root and one root will get cancelled here. Another one root will be remaining. So your 30 square plus 40 square is nothing but 50 square. Okay, so this will be 100 P into 50 by 40 into 50 square. So cancel out what all will cancel. 1s are 2s are 2 1s are 2 2s are. So you will get a P by 2. This is the maximum shear force in the bolt which is due to the moment M. Right. So now let me change the color and write it. So you need the vertical shear force and you need the maximum shear force because of M. See, generally if there is no eccentricity, you don't have to calculate this. Directly the vertical shear force you can use for your calculation. So I will call this as FA and this as Fm. Force because of loading and force because of the moment. So how will you get your maximum resultant shear force? So he wants you to calculate the maximum force in the bolt. So you have to sum up both the forces because of load, both the shear forces because of load and because of moment. So your maximum resultant shear force Fr will be equal to what? Under root Fa square parallelogram. You can apply the parallelogram theory here. Parallelogram law. Fa square plus Fm square 2 times of Fa Fm cos theta. So cos theta will be how much? This total is 100, right? So exactly here it will become 50. So cos theta will be equal to what? 30 by 50. Nothing but 3 by 5 it will be. Okay. So do the calculation. Let me do the substitution for you. So what will it be? Under root Fa is P by 4 whole square plus P by 2 whole square plus 2 times of P by 4 into P by 2. Cos theta is nothing but 3 by 5. So P square, P square, P square, I'll get it out of the root. So I'll be remaining with 1 P. and on this calculation I will get root 37 by 50. So it's better you put it into decimal, 0.68 p. Okay, so the correct answer for this particular question is how much? 0.68 p. Okay, based on rounding off, you please do the calculation. If they ask you up to one decimal place, write as 0.7 p. If they ask you two decimal place, keep this as it is. Okay. I hope you all understood how to do this problem, right? So let's get into the next problem, welded connection problem. Okay, I had made two slides. Okay, chalo no. What is he asking you? There are two plates subjected to direct tensile axial tension. Okay, each 16 mm thick with width of 150 mm and 300 mm respectively are to be fillet welded. Okay, we have to do fillet weld here. There are two plates which are of 150 and 300 mm. So the yield strength and the ultimate tensile strength of the steel is given to you as 250 MPa and 410 MPa. So the yield is Fy, that is given as 250 MPa, and the ultimate is Fu, that is given as 410 MPa. Right, the weld is done at a size. So they have given gamma MW standard they have given, or else they will tell you the type of weld we have to generally choose. Okay. So the joint is subjected to a factored load of 250 kilo Newton. So what is 250? 250 is nothing but design load factor and load. How much is this? How much is this? 250 kilo Newton. What does he want you to calculate? The minimum length of overlap in mm required using the minimum permissible weld size. So by using minimum permissible weld size, what will be the minimum length of overlap which we have to have in order to connect the two plates is what he is asking you. Okay. Now first is the size of weld. So in the question he is telling he wants to use what? The minimum permissible weld size. Now according to the IS code, 5 mm is the minimum permissible weld size. Now this is according to the table 21 of IS 800 2007. Now we need to do what? Design. We have to calculate the design strength of the fillet weld. So how will you calculate? PDW, nothing but Fu by root 3 gamma MW into LW into throat thickness. So Fu is given 410, root 3 gamma MW is given 1.5, LW we don't know, that is what we are trying to calculate, right, into the throat thickness. How much is the throat thickness? 0.7 of the minimum size of weld. So this is standard. 0.5, this is standard, this is standard. 0.7 is the throat thickness. Hello Ajay, welcome to the class. Right? So substitute everything and do the calculation. You will get what? 552.33 LW Newton per mm. So this is what the design strength of the fillet weld. If you observe, this design strength is greater than your design load factor. Right, very important. So the design load factor, or and you take and load is less than, should be less than or equal to the design strength of fillet weld. Okay, this we have is 250 into 10 power 3 Newton. This should be less than or equal to 552.33 Newton per mm square into LW. So based on this, what would be the value of LW? It will be 452.628 mm. Okay. Now how much will be the length of overlap? Length of overlap will be equal to 452.628 minus 150 by 2. So this will be 151.313 mm. Why 150? Because we have to choose the minimum width of the plate. Okay, so that is how you will get the length. So the correct answer for this according to the 3 decimal place is 151.313 mm. Okay, next, moving on to the next question, next 2-mark question. So what is it saying? An IAS 200 into 100 into 15 mm is connected with a gusset plate. So there's an angle section, unequal angle section of 100 into 200 and the thickness is 15. This is connected to a gusset plate which is of 12 mm thick with 3 16 mm diameter bolts. So they've used total number of bolts as total number of bolts which are there as 3. The diameter of each bolt is 16 mm and the grade given is 4.6. So the net area of the section has to be calculated. Okay, so how will you calculate? First of all, effective net area. See, generally, according to your code, as per your IS, direct formula. Yes, we can do it by direct formula. Okay, so according to your IS 800 2007, so how much is your effective net area? It's given by ANC. So your ANC is nothing but alpha A N. Okay, how do you calculate alpha? See how many number of bolts are there? There are 3 number of bolts, right? For 3 number of bolts, the alpha value is equal to 0.7, right? So if you want ANE, how will you get 0.7 into AN? First of all, you have to calculate the value of AN. Okay. So how will you calculate the value of AN? So for ANC plus AGC, you have to do. So how will you do this? See, first here the length is 200. Okay, so that 200, from that 200, you have to subtract the nominal dia. Generally, this is the given diameter. Okay, so I'll call it as D naught. So what is nominal diameter? D naught plus D plus 2. So 16 plus 2, that will be how much? 18. So from this, subtract 18. Again from this, See, the thickness is 15. So here also 15 will be there. Here also 15 will be there. So here what will happen? You can divide that into two legs. One in this leg and one in this leg. So I'll put 15 by 2. This total into the thickness. Okay. Plus again your AGE we need. How much will be AGE? This for this 100. Okay, directly there's no bolt here. Directly just subtract your 15 by 2. Understood? So that's how you'll get. This is for this leg NCA, NC I'll call. This I'll call as AGE. Understood? Now how much on calculation will you get this equal to? This will be 2617.5 and this will be 1387.5. Yes, Ajay, please ask. mm square. So on addition, this will be 4005 mm square. Okay. Now the net area of this section ANE will be equal to 0.7 times of 4005, which will be equal to 2803.5 mm square. Do we have the option here? Yes, we have the option, which is option number C. Okay, I hope it's clear. I hope it's clear, right? So basically we have to calculate for both the plates and then that has to be multiplied by the number of bolts. Why number of bolts? If you see in the longitudinal way like this, there will be 3 bolts. No, that much of portions will be removed from the gadget plate as well as from the angle. Okay, chalo then. Let's get going to the next question. What will be the strength of the 20 mm dia bolt of grade 4.6 in kilonewton for the double cover butt joint and 8 mm thick cover plate? The main plates to be joined are 14 mm thick. Use Fe 410 grade steel. Assume end distance E as 33 mm and pitch P as 50 mm. And shear through net area section of the bolt. So we have to go on doing the calculation and we have to basically find what the strength of the bolt. Okay, so from where shall we start? Now they've given the grade. How much is the grade? See here, how much is the they've used Fe 410. Okay, so for Fe 410 grade steel, your Fu will be 410 Newton per mm square and your Fy will be 250 Newton per mm square. And also they've given you the bolt grade as 4.6. So for 4.6 grade bolt, your FUB, the F ultimate for the bolt will be what? 400 Newton per mm square. So whatever this value number will be there here, that will be the factor. Okay. Now, the safety factor for the bolt material gamma MB will be 1.25. Generally, for all places, it will be 1.25 only. Now, what will be the net area of the bolt? So, let us calculate the net tensile area for the 20 mm dia bolt. I'll call it as A and B. So, generally, how is that? Your 0.78 times of your bolt dia. So how much is 20 mm is the bolt dia given? See here. Okay, so this value will be 245.04 mm square. Right. Now next, after you calculate that, you know that the bolt is double covered. Okay, where is it? Here. It is double cover. So the bolt will be in double shear and bearing. Okay. So the thickness will be minimum of 8 divided by 8 or 14 mm. Now, next what we have to do is we have to calculate the strength of bolt in double shear. So we have a standard formula for this. VSB, which is 2 times of FUB into ANB by under root 3 gamma MB. So 2 times of FUB is 400, ANB is 245.04 by root 3 of gamma MB is 1.25. So how much will this be? 90.54 kilonewton. I have written in kilonewton. You'll get the answer in Newton. Just convert it into kilonewton. Now this is the strength of the bolt in double shear. Now I have to calculate the, okay, let me take one additional slide. Hmm. Now I have to calculate what? The strength of bolt in bearing. So how much will it be? VDBP, this is again a standard formula, which is 2.5 of kb into dtfu by omega mb. Now here for the diameter of 20 bolt and d naught will be what? 22 What will be kb? Kb will be the minimum of E by 3 d naught. E is nothing but they've given here the end distance 33 by 3 into d naught is 22. So this is 0.5 or it will be P by 3 d naught minus 0.25. Pitch, how much is pitch? 53 times of 22 minus 0.25. How much will this value be? 0.508 or it will be FU by FU. So FUB is 400, FU is 410. So this will be equal to 0.976 or 1. Right? We have to choose what? The minimum. See which is minimum? This 0.5 is minimum. So the KB value will be 0.5. So just do the substitution. 2.5 into 0.5 into the diameter is 20 into the thickness is 14. They've given here. Okay. So this is diameter. This is thickness. Diameter 5 or D. Okay. Into FU is 410 whole divided by 1.25. Okay. So on simplification, how much you will get this? 114.8 Newton. This is the strength in bearing. Now in both of them we have to choose the minimum. So strength in bearing is, let me write, VDSB is a strength in bearing. No, VDSB is in strength in double shear. VDPB is strength in bearing. Strength in bearing is 114.8 kilonewton and this we got as 90.54 kilonewton. Now what we have to do? We have to choose the minimum of 2. So finally the strength of the 20 diameter bolt will be equal to your 90.54 kilonewton. So that will be the answer for this. This is how you'll have to calculate the strength of the bolt which is in double shear. So you have to take care of bearing as well as the shear. Okay, next. Moving on to the last question of the test. So what does it say? An angle, an equal angle 75 mm into 75 mm at 11.0 kg per meter is subjected to a load of how much is the load? 200 kilo Newton, whose line of action passes through the centroid of the section, which is at 22.2 mm from the heel. Okay, so basically we have one gadget plate here, some gadget plate you take or whatever. For this there is an angle section. This is equal angle section, right? So ISA 750 into 750. So this distance will be how much? 75, sorry. 75 into 75. So this distance also will be 75 mm. Now, what is telling is the centroid of the section which is at 22.2 mm from the heel. Okay. Now, this is your heel of the section. Right. From here, the centroid is at 22.2 mm. So, how much is the remaining distance? The remaining distance is equal to 52.8 mm. Okay. So, if you extend this like this, how will this look? See, extend, I'm just extending. So, how will your diagram look? This is your plate. Okay. Onto this plate, you have your angle. So, here there will be one force P1 and here there will be another force P2. Now, this much will be the length of your weld which you are giving into the structure. Okay. Now, the angle is to be welded to a gusset plate if the size of the weld is to be 8 mm. So he has given you the size of the weld. How much is the size of the weld given to you? 8 mm. What would be appropriate length of the side fillet weld required at heel and toe respectively? So we have to calculate the size of the weld. Okay, first what we have to do, see here if there are two forces P1 and P2, there will be an opposite way of force which is nothing but P here. Now, say if I take up the calculation, first of all taking moment about the line of action of P2, we will take the moment about the line of action P2. Okay, so how much will it be? How will you do? So it will be 75 P1 equal to 200 into 10 power 3 into your 52.8. Correct? So from here, what is the value of P1? 140800 Newton. So what will be P2? P minus P1. How much is P given to you? 200 kilonewton. So 200 minus 140800. So this will give you a value equal to how much? 59200 Newton or 59.2 kilo Newton. right? So what will be the strength of the weld per mm now? Per mm will be 0.7 into the minimum size into the tau VF which we got. So how much it'll be? 0.7 into 8 into 110. That will be 616 Newton. So that is your answer. So on this, based on this strength, if you go on dividing your values, so he wants the length of the fillet weld required at the heel as well as the toe. So at the heel, we need 230 mm and at the toe, we need 95 mm. So this will be your correct answer. Okay. So that was about the mm test questions. So in the next coming week, you will have test questions on tension members, compression members, as well as flexure members. Okay, so whatever test questions will be solved on the Sunday's class, Sunday whatever test question will be conducted. So on Monday's class, we will be going to take care of the test questions or do the solve the test questions. Okay, now so there's still time available. So let us solve some additional questions or additional problems. Uh, so we will take up bolted connection. Okay, this is a question. Some random questions I've chosen to be solved. Might be help. These will be helpful for your uh, gate exam. Okay. So what they're asking to determine the strength and efficiency of the lap joint. So this is a lap joint. There's bolt given here. So you can see, so this is your plate. On this plate you have the holes like this. Okay, overlapping of plate. This top plate is still here, this bottom plate is still here, so you can see the overlapping. So these are your bolts. Okay, now the bolts are how many dia? 20 in dia, and the grade of the bolt is 4.6. The two plates to be joined are 10 and 12 thick. Okay. Chalo, then let us start doing the calculation. First, let us write all the details regarding the bolt. So the dia of bolt is 20 So what will be the nominal dia? 20 plus 2, that is nothing but 22 Then what will be your shank area? How will you calculate? ASB, this is nothing but pi by 4 of 20 square. So each bolt shank area will be 314 square. And how much will be the thread area? Thread area is nothing but ANB, which is 0.7 of ASB. So this is standard, not 0.7, 0.8 of ASB. Okay, so 0.78 of 314. So this will give you a value of 245 square. Then they have told the grade of the bolt is 4.6. So your FUB will be equal to 400 MPa and your FYB will be 0.6 times of FUB. That's nothing but 0.6 times of 400, which is nothing but 240 MPa. Now here in single shear, your NN will be equal to 1 and your NS will be equal to 0. So this is all the details regarding the bolt given to us. Now coming to the plate. The plate one is 12 thickness And the plate 2 is how much? 16 mm thickness. Okay. See, this here is 12 and 16. That's why I got confused. Okay. 16 mm thickness. Okay. Now, what else is given? They have given E250. E250A grade plate. How can you decide on that? How can you decide on that? Because the thickness is less than 20 mm. Okay, that's why we can decide on that. Then your Fy is 250 MPa and Fu is 410 given to us based on the grade of steel. So 410 MPa. So these are all the details which are given to us. Now we have to do the design. So first we have to calculate the shear strength. So see, once we have written all the data which is given to us and what data is required, it's very easy. It's just formula and substitution. So what will be the shear strength? VDSB, that is nothing but 1 by gamma MB into FUB by root 3 into NN ANB plus NS ASB. So all these values we have previously calculated, and gamma MB, if it is not given, you can assume to be equal to 1.25 for bolted connections. Okay, so 1 divided by 1.25, UB is 400 by root 3. So 1 into 245 plus 0 into 314. So this will be equal to 45.27 kilo Newton. Then after that we have to calculate VDB. How will you calculate the VDB value? So VDB is nothing but 1 by omega MB into 2.5 into KB into D into TFU into FU. So here the main thing is to calculate your KB. So KB, just now we in some previous problem we did, it is nothing but the least value of four things. Okay, so least value of what four things? E by 3D naught. E is nothing but 35 into 3 by 22. See, here they have given edge distance. This is your edge distance. 35 by 3 into 22, 0.53. Then, or it is P by 3D naught minus 0.25. Pitch we can take as 70. 70 by 3 into 22 in minus 0.25. So this is giving a value equal to 0.81, or FUB by FU. FUB is 400, FU is 410. So this will be 0.975 or 1. Now out of this, the lowest value is 0.54. So your VDB will be equal to 1 by 1.25 into 25 into 0.53 into the diameter is 20, right, into the thickness. You have to take the least thickness. So I'll take 12 into, after thickness, what is there in the formula? FU. FU is nothing but 410. This will give you the value of 104.3 kilo Newton. Okay, now out of these two, the bolt value is the lesser of two. Okay, so out of your VSB and VDB. So out of VSB and VDB, choose. Chinna, welcome to the class. Good evening. choose the least of 2. So what will be the bolt value? The bolt value will be equal to VDSB is only lesser, so 45.27 kilo Newton. Next, we have to calculate what? Actually, we need the strength, right? Now, for that, first you try to calculate what is the yield of your gross cross section of plate. So, how much is this? TDG will be equal to AGFY by gamma M naught. So, AG is 320 into 12. How you'll get 320? See this addition. Add all this, you'll get 320 into smaller plate, right? So that will be given to you. How much is 250? And sigma m naught standard 1.1. So this will give you a value of 872.7 kilo Newton, right? No or rupture strength of TD will be equal to 0.9 into F sigma ml. So where is, how do you calculate AN? AN will be 20 minus 2 because there are 4 bolts here, 1, 2, minus 4 of 22 into the thickness of plate 12. Okay, that is the net area or 84. So now you do the substitution, 0.9 into 278 U is nothing but 410 whole divided by sigma 1.25. 8 to 1.8 kilo is nothing but your TDN. Okay. So now what is the strength of the bolt in shear? So there are 8 bolts. We have got the, let me write each one of them. Strength of bolt in shear. So we got 45.2 into 8 bolts, that will be 362 kilo Newton. Then strength of bolt in bearing, this we got as 104 again into 8 bolts, so this will be 832 kilo Newton. Then strength of joint in yielding, we got it as 872 kilo Newton. Then in rupture also we got 821 kilo Newton. See, in yielding 872, in this one 821. Then the strength of joint itself is 362 kilo Newton. Okay. Now, how will you calculate the efficiency? They have also asked you to calculate the efficiency. Generally, the efficiency is equal to strength of joint by yield strength of solid plate. So, strength of joint is 362, yield strength of solid plate is how much? 872 into 100. So, 41% will be the efficiency. Okay. So, efficiency generally is calculated by the formula what? Strength of joint by yield strength of the solid plate. Okay. Now, this was about the lap joint problem. We will do one more problem wherein we'll calculate the strength and efficiency. Now this is for the bolt joint problem. Okay, so if you observe that this is a different type of connection. Okay, but generally most of the values will remain same. Okay, so calculate the design strength and efficiency of a bearing type connection for a bolt joint as shown in the figure. Two plates of 16 mm thickness are used, 20 mm bolt of grade 5.6 and two cover plates of each 10 mm thick. So this and this are cover plates, these are 10 mm thick. These data is given. So let us write all the data first. So regarding the bolt, the data regarding the bolt. So diameter is 20 mm. So D naught will be what? 20 plus 2, which will be equal to 22 mm. Then we have to calculate the ASB value. How much is this? Pi by 4 of 20 square, which is 314. So this will be how much? 314 mm square. Then A and B will be how much? 0.78 into your ASB. So that will be 245. So 0.78 into 314, that will be 245 mm square. FUB will be what? 500 MPa. Okay. So how much will, these are all details regarding the bolt. Now let us do the details regarding the plates. Write the details of the plates. What is the thickness of the plate? 16 mm, and thickness of cover plate is given as 10 mm. If you observe, both the thickness are less than 20 mm, right? So E250A grade we will be assuming. Okay. Now what will be FU in that case? 410 MPa, and your Fy will be equal to 250 MPa. Then double shear details. So what NN and NS will be equal to 1. Your pitch is given as 80 mm. See here, pitch is given as 80 mm, and your edge distance E is given as 40 mm. See here, this is your edge distance. This is pitch between the bolts. Okay. Now, what is the next thing? This is end distance. Again, edge distance. Again, here this is given as here. This one. This is your edge distance. This is E naught, the edge distance. How much is this? 35 mm. Okay, this is edge. This is end. Right. Now, first calculate shear strength. So VDSB. So how much is it? 1 by gamma MB into FUB by root 3 NN ANB plus NAS ASB. Okay. So do the calculation. 1 divided by 1.25 if bolted connection is given. 500 is FUB root 3 into 1 into 245 plus 1 into 314. Okay, this again a square bracket here. So how much will this be? 129 kilo Newton. This is what? Shear strength calculation. Now you have to do the bearing strength calculation. So for bearing strength, what is your formula? VDPB will be equal to 1 divided by gamma MB into 2.5 into KB into D into T into FU, right? Here main important thing is KB, which is the least of these four, E by D naught, P by 3D naught minus 0.25, FUB by FU or 1, whichever is least has to be chosen, okay? So E is 880, 3 into D naught is 22, E is not 80, E is 40. P is 80 divided by 3 into 22 minus 0.25. FUB, how much is FUB? 500 by FU is 410. So this is coming as 1.21 and 1. So this calculation we didn't do, no? 0.61 and this is 0.96. So the least is what? 0.61. So substitute in here 1 divided by 1.25 into 2.5 into KB is 0.61 into D is 20. Thickness 16 is the thickness of the plate and FU is 410. So on calculation, how much are you getting this? 160 kilo Newton. Now the bolt value will be what? The bolt value will be the least of two, 129 and 160. What will you choose? Least of 2. So the bolt value is equal to 129 kilo Newton. So once you're done with the bolt value, you have to calculate the yield strength of the plate and the tearing or rupture strength of the plate. So first let's do the yield strength. So how much is the yield strength of the plate? TDG equal to 0.9 AN into FU by sigma ml. So 0.9. How will you calculate your? No. This is the tearing or rupture, not yield strength. Let me just change. This is what? Tearing bar rupture strength, TGN, supposed to be called as TGN. Okay. Now AN, how will you calculate? B minus ND naught into T. So 280 is the total breadth. This total, okay. If you add all of this, you will get 280 minus N number of bolts into the nominal dia of the bolts into thickness of the plate, that is 16. So this will get us 3072. So 0.9 into 3072 into FU is 410 whole divided by 1.25. This is standard. Okay. So how much will you get? 906 kilo Newton. So this is for tearing or rupture strength. First we had to calculate yield strength, but since I wrote that formula, I just calculated it first. So yield strength is given by what? TDG, which is nothing but AGFY by omega sigma MO. AG is the gross area, which is 280 into 16 is the thickness, multiplied by your Fy, which is 250. 1.1 will be your sigma MO, 1018.18 kilo Newton. So these are all your calculation. Now if you want to calculate the strength of joint, how will you do? First is strength of bolt in shear. How much did we get? We got 192, but there are totally 8 bolts. 1, 2, 3, 4, 5, 6, 7, 8 bolts. So into 8, we'll get 1032 kilonewton. Then in bearing, we got 160. Again, there are 8 bolts. So we'll get 1280 kilonewton. Then the strength of the plate in yield. In yield is how much? 1018.18 kilonewton. And in rupture, it is how much? 906 kilo Newton. Right. Now, how will you calculate the efficiency? The efficiency N will be equal to the rupture 906, the smallest one, divided by the yield, that's 108.18. So that will give you an 88.99% efficiency. Okay. So if you observe in the lap and the butt joint, your butt joint is more efficient. You can see it in this problem calculation, right? Okay. Now let us do one example of welded connection. So determine the service load permitted on the connection in which an ISF 250 mm into 12 mm in size is welded to a 10 mm thick gusset plate by a fillet weld. So the type of weld what they have chosen is a fillet weld. Okay, use weld size as 6 mm and overlap of member is 280 mm. Overlap also he has given. Use a steel of Fe 410 grade and shop weld. Okay, so what all details has given, from that what all you can extract. So for Fe 410 grade steel, Fu will be what? 410 MPa and Fy will be what? 250 MPa. And for shop weld, gamma MW will be 1.25. What will be the effective length? So the effective length of weld will be, see here, 250 plus this as well as this. So because the weld is done from here to here to here. Okay. So 2 times of 280. So 810 mm. Similarly, we have to calculate the effective throat thickness TT. This will be nothing but Ks, right? K into S. Now K value based on this, it will be 0.7 into 6, which is nothing but 4.2 mm. Now what will be the design strength of the weld? Standard formula, design strength of weld will be equal to LW. So I'll call design strength of weld as PDW. So it will be LW into TT into FU whole divided by root 3 sigma MW. Okay, LW is 810, throat thickness is 4.2, FU is 410 by root 3 sigma MW is 1.25. So how much will you get? 644 kilo Newton. But in this he has asked you the service load. So the service load will be the total design load divided by the factor of safety. Since nothing regarding the factor of safety is given, you can choose it as equal to 1.5. Okay, so that will be 429 kilo Newton. Okay, do we have an option? Yes. See, a lot of them tend to go for this design load of the weld only. They will try to tick the option, but it will be wrong because this term is very, very important. He has asked you to calculate the service load. So you have to divide it by the factor of safety. Okay. So this will be your correct answer. Let's do one last problem on the U-groove weld. Okay, so it's telling 12 mm thick plate are joined by a workshop by a single U-groove weld. The effective length of the weld is 250 mm. Determine the design strength of the welded joint which is in tension. The yield and the ultimate strength of the weld and steel are so and so. Okay, so now they have done it in the workshop. So since it's been done in the workshop, your sigma mw again is equal to 1.25. Fu is given as 410 MPa is nothing but FUW. Why? Because they've told it is same. See here, the yield and ultimate strength for weld as well as steel both are same. Okay, so then Fy is 250 MPa, which is nothing but your FYW. Then now we have to calculate the effective throat thickness. So the effective throat thickness TE is 5T by 8, nothing but 5 by 8. Thickness is given to you in the question 12 mm thick plate. So into 12. So this will give 7.5 mm. Then the effective length is already given to you in the question. The effective length of weld. So LW, this is nothing but 250 mm, again already given. So how will you calculate the strength of the groove weld? So the strength of groove weld will be given by TDW, which is LW TEFY by omega MW. So LW is 250, throat thickness is 7.5, Fy is 250, whole divided by 1.25. So this will give you 450 kilonewton. Do we have? Yes, we have the option of 450 kilonewton. This is how you'll calculate. See the standards you need to remember. Once you know the standard, any problem in steel structures will become very, very easy for you to do. Okay. So we will again meet next Monday on the same Ekeeda YouTube channel. So if you haven't subscribed it, please do like, share, and subscribe. Also, press the bell icon so that you will get regular class updates. And for the people who are new and don't know about the Ekeeda app, in the description box you can find the link to download the app, or you can go to Play Store and also type Ekeeda and get the app. So you will get a complete 3 days free access for all the courses on the Ekeeda app if you use the coupon gold 11. So you can have a look on that. You will have professional courses, competitive courses, your academic courses for all engineering branches. Okay, so or if you have any doubts, you can call us on 9029006464. We will assist you in taking up any subscriptions. We have three types of subscriptions: silver pass, gold pass, and platinum pass. So you can use those passes, or individual subjects if you want to also take. If you're weak in any single subject, that particular type of subscriptions also is available with us. Okay, so that's it for today. Have a good day. We'll meet again next Monday for the test solutions on tension, compression, and flexural members. Okay, I hope the class was useful. Bye bye. Take care.